Are you a farmer? You ever feel like repeating the same thing over and over isn't for you? Well, it's time to automate. What's up, everyone? Grimli here, and welcome to The Farmer Was Replaced. This game is apparently about coding and automation, and for a bit of background, a long time ago I did some work in Java and Rust, and this game is supposed to be more similar to Python, which I have never dealt with, but I'm up for the challenge. The game is fully releasing 1.0 today, the 10th of October, 2025, and I hope you enjoy me figuring things out. But yeah, I guess we just hit start. Getting started. This window contains information about everything in the game. You can move windows around by dragging and dropping the gray part of the window. Move around by dragging anywhere outside the windows. To get started with programming, go to the first program page by clicking it, and be sure to check out the buttons at the top right corner of the screen. Hover over them to see a tooltip explaining what they do. One of them opens the tech tree. Create a new code file, new info, and unlock tree. While unlocks a simple while loop. While true, harvest. Okay. Interesting. The speed of the drone, the yield. Okay. Unlocks plantings. So I guess we're gonna. Okay. So I guess we just click here. Okay, first program. So, first program, a text editor. All programming is in code windows. Each code window corresponds to a text file containing code. You rename the file by clicking its name at the top of the window. The code can be edited like in any text editor. As long as it's not running, you can execute the program directly by pressing the green play button in the code window. And you can create more code files using the plus button in the upper right corner of the screen. You can dock a window to another window by dragging it onto it. And you'll notice that once you start typing, a simple code completion window will pop up. Press tab to insert the code completion. Use the arrow keys to navigate through the completion options. Don't worry if this is first time programming. The language is unlocked step by step, so you won't be overwhelmed by all the things you can do. Yep, there it is, similar to that of Python, which is one of the most widely used programming languages in the world, and learning is not completely wasted. If you already know Python, it's not a problem either. You'll be able to skip the early game quickly to get to the more interesting stuff. Currently, there are only two drone commands available: harvest and do a flip. These are function calls. You can think of a function as a command that can be executed. You can execute it using the parentheses. Typing the statements in the code window and pressing the execute button. You can think of your code as a sequence of statements. You can write multiple statements in a row like this. Harvest, do a flip, harvest. Okay, can I copy here? Can. Alright, unlocks collecting grass will give you hay. Hay can be used to unlock loops in the unlock menu. Open the unlock menu with the button in the top right corner. Alright, so I guess we just execute. Cute. Alright, so it's throwing it into the piggy bank there. Nice. Alright. So we need 5 of this. We have 4. So we just run this one more time. We have 6. We can unlock a loop. Good. You've unlocked the while loop, and the value is true and false. The while loop keeps executing the loop body as long as the condition is true. So while condition colon... and then you have it tabbed out. I don't know if that matters. Don't worry about creating infinite loops. The delays in execution will prevent the program from freezing. Okay. For beginners, perhaps you have already tried to put harvest calls in a row. It allows you to harvest several times in one program run. However, it would be nice to harvest more than 3 times. And writing the same code multiple times is bad practice. The solution is a loop. A loop allows you to run the same code multiple times. The while loop takes a condition, which is a logical value that can only be one of 2 states, true or false. Such a value is called a Boolean value. The loop then executes the code inside the loop until the condition is false. The while loop looks like this. While loop, yep. And where you have to replace condition with a Boolean value and loop body with whatever you want to do in the loop. There are 2 constant Boolean values available. Constants are values that never change during the program. So I guess what I would want to do, the condition, I would want to check this, like while hay is less than a certain amount of, I don't know, we would loop. Change constant Boolean is always true. You can simply write true, right? While false will always be false. You can either write while false do a flip or while true do a flip. First will never do a flip, and second will do flips forever, an infinite loop. Normally creating it, bad idea. Yes, it will freeze. In this game with the delays, cause the drone to keep doing a flip until you manually stop by pressing the execute button again. Notice how the line after the colon is indented. Indentation like this will be used to separate blocks of code. Press tab to add it. Okay, so it is just paying attention to the indentation. Okay, I'm used to like putting it around brackets or something else. Statements after the indented block will be executed after the loop has finished. So, do I just loop this for a bit then? So, while, you just put true, colon, and then harvest. I guess I just tab it over here. All right. And then run that. I mean, that seems pretty easy to me. Okay. So now we are harvesting faster. That's totally not something that you would do in video games after a kill. No. Speed upgrade. The execution speed has been doubled. The problem is that the drone now harvests faster than the grass can grow, resulting in no harvest at all. Oh, okay. To deal with this, if branches and the can harvest function are now unlocked. So checking before harvesting. So far we only had true and false, right? Which is of course not very useful with if. So while true, if can harvest. And then do we have an else? Do a flip? Sure, why not? That's the only other thing I know. Else do a flip. All right. Oh, yeah. Sorry. Else. Okay, we can get rid of this, I guess. So it's going to harvest as fast as it can now, I guess. Interesting. Okay. Get hats. Okay, so we need logs. Interesting. All right. Grass. Ah, looks like we're supposed to expand first before we get more grass. All right. So I guess we can just collect for a little bit. All right. So your farm is grown. The space is not much use if you can't move the drone. So there is now a function move. Requires you to specify north, east, south, and west. For example, move north, we'll move the drone 1 square north. If you move it over, it'll move to the other side. Okay, so, all right. Let's stop this then. So we can go move north. Afterwards, we'll check that first. So if can harvest, then move north. And we'll just do that. How did it go? Oh, move in parentheses. Okay. All right. That seems like it works. Cool. All right. So it's just looping around. It doesn't have any detection for edges yet, I don't think. So what's next? I guess we unlocks planting. So grass is nice because it grows automatically. All of the plants have to be planted with the plant function. So the plant you can plant right now is a bush. You can pass the type of plant you want to plant to the function like this. So we'll plant a bush on the drone. Call clear to reset the farm to all grass and reset the drone position. Seems that if you grow more than one type of plant at the farm at the same time, you sometimes get a higher yield. You'll need to research polyculture to learn more. Okay. So I guess we'll put a bush down. So else plant entities bush. Let's see what that does. Okay. I was hoping it would do immediately. I see what's going on here. So we're never hitting this else because as it moves along, it's fast enough. I guess we could just put it inside of that. We could check this twice. Or yeah, actually we could put the plant right afterwards. let's swap these two. So we'll put this right here. And we will do the else move. Interesting. Huh. Well, that's kind of fun. And we can call clear to reset the farm to all grass. So how do we get the more than one type of plant then? How could I maybe just get one of these as grass? Let's look at that real quick. In our loop, if we can harvest, we're gonna harvest. Instead of just moving north, what if we went ahead and played with this a little bit? Like maybe we want to do grass on the bottom. Let's move this out quick. So if can harvest. And then we want to move north. We want plant here. And then another move north. Let's get rid of this. So we're going to plant regular here. And then move north to this spot. Or any of the spots. And then harvest it, plant. And then we're going to move north again. Plant. And come back up here without planting. Let's see how that works. What I'd like to do is harvest that a few more times. But I don't know how to limit a loop. This spot here with just the bushes. Food for thought. But we do have plenty of hay and wood, so let's go ahead and see if we get some unlocks and do that. So, we got the plants. We need 300 for more yield. Speed seems good. Ah, expand. We need a couple more for that. So let's run that just a little bit more. And then we can get a bigger farm. All right. Cool. So expand 2. Your farm is expanded again. Now the tiles are no longer in a nice row. So you need to find a way to traverse a square grid. With a while loop, this is not possible until you unlock senses and operators. It is time to introduce the for loop. Hey, there we go. To limit a loop. So you can read the for loop in the for loop page, but now you only need to repeat the code for a fixed number of times. So for I in range, do a flip. Range creates a range of numbers from 0 to n minus 1, which has n elements in it. The for loop runs its loop body once for each element in the sequence. Example, do a flip will be called 5 times. The function get world size is also available now. It returns the side length of your farm. That way you can write code that won't break with the next expand upgrade. Oh, I like this. This is cool. Okay, so we're going to just run this for a while, true loop. And then for I in range, get world size. I wonder if that's the side length of your farm. Is that the left side? The bottom side? Is this always going to be square from now on? I'm not sure. We won't click the hint. That's kind of cool that they have the hints, though. But, okay. So we're going to, for I in range, get world size. If can harvest, we will harvest. And then we move north. And we need to move this out. Okay. And then what we can do is maybe alternate these. So can I divide this by 2 perhaps? I don't know. I guess I could just alternate between regular harvests and planting. harvests. We'll just do a row each. That seems fine. So we want to do this again. And again. Except we're adding in the plant. Okay. So this should alternate. We need to move in between the 4 loops. So move east, I guess. And then move east. So in theory, this should plant every other, I'm guessing. So let's see what happens here. That works good. Cool. That worked exactly like I thought it would. All right. So what does the hint say? There are several ways to move around the farm. Vote traverse, say the systematic way won't break when this farm grows again. Systematic way to get in place in the farm would be to repeat this following 2 steps forever. North until it rests back, and then move east. That's exactly what we did. Brian, range, get world size may be helpful to turn this idea into code. Yeah, we could do... Instead, they're doing this instead of the while true. Yeah, that makes sense. Okay. Yeah, 3 easts. Interesting game. I like it so far. Okay, so unlock tree. Let's see what we got. Oh, we need carrots for that. Okay. We have enough for the yield. That's nice. Carrots for that. We can unlock hats. New hat colors. Oh, that's exciting. Oh, I guess we could... Oh, you know what would be kind of fun? We put on a different hat based on what we're planting. So let's do a change hat. I guess we have brown hat for the bush. And I guess a green hat for grass. All right. Grass is green, right? Oh, I broke something. Why does it disappear? Oh, that's an interesting interaction there. All right. So I know this game came out today. However, I am still on a bit of a beta branch. So there might be some bugs. Maybe we get rid of the brown hat thing? I think it was a brown hat. Let's get rid of the hats in general. Oh no. Oh, it's just gone. Let's add in a green hat again. Or maybe clear it. There it goes. All right, that was something else. Okay. Ah, we have a debugger is next. Interesting. Oh, then we can unlock carrots here. Okay. Okay, well, debug. Sometimes your code doesn't work, and you need to find out why. Their code tools will help you do that. First is execute the program step by step. Go step-by-step mode with the button next to the execute button, or by setting a breakpoint. Breakpoints can be added by clicking the breakpoint panel to the left of the code. When execution reaches the line where the breakpoint is, it will automatically switch to step-by-step mode. Move your mouse over variable. Current value is displayed. Cool. All right, and we also have print 0.24, print true or false for the current position. Quick print only prints to the output window. So I guess we could see that if we want. It was just print. Do I have to put in quotes? I didn't see. Why did I close that? Okay. So yeah, in quotes around the text. Grass. Bush. Huh. Cool. Super slow. Okay, and then we have the print quick print. Only found on the output page. Okay, so I guess tab complete doesn't take care of that. So where is the output page? There it goes. It doesn't scroll. So that's kind of cool. I guess we need carrots to do some more speed and expansion, so let's just do that. Okay, so plant entities carrot. Oh, I have to till. Change the ground to grounds.soil. So we call till, calling till again, we'll change it back to grounds grassland. Oh, and it costs. Okay, interesting. Okay. So let's do this. So we'll just add in basically another statement here. We're going to put this, and let's get rid of these quick prints. I don't really need these yet. All right, so on our main here, what I'd like to do, of course, first we want to harvest whatever's there, and then if it, oh, we don't have ground type yet. Is it 2 equals? I have no idea. Does not equal. What I want to do is check to see if it's not soil. Does not equal soil. Till. And then we're planting carrots. Entities. Carrot. Okay. This is what I'd like to do. I have no idea how to actually do this statement yet, though. Let's see what happens if I just run this, though. Unlocks. Operators must be unlocked before this can be used. Okay, well, let's just play with this then. Let's pull that out. Let's see what this does. I knew it. Okay, so that's what I thought. How do we check to see those carrots? I have no idea. Yeah, we can't, we can't check to see if it's been tilled or not. I guess we could run one pass. Okay, so every time it clears, it looks like the robot runs up the top left. So what I can do is run this. And we're just going to till on one row. And then we can do this one first. So we will do the carrots on this first row. See if that works. Oh, that is not what we want. Till, move north. There we go. That's working. No. Or maybe it is? Oh, that seems fine. Yeah, those are still growing. Okay, cool. Interesting. All right, that seems good to me. It's a little messy, but it seems fine. Let's see what else we got here. We should have some unlocks on. We have a few carrots. We need 50 carrots for speed. All right, here we go. So we're going up to 4x4. This is going to mess up everything. Let's do that. Yep, and we just broke everything. Do we have a fourth plant that we can unlock? I don't think we do. That would be very convenient. Oh, hey. Almost. Almost unlock trees. Oh. Unlock watering. Use item water? Do I even have water? That seems interesting. Okay. Oh, operators! That's what we needed. I was looking for this. Okay, it's on the right. I didn't even... Oh, I was so caught up with all this. Okay. This is what we want. We want operators. Ah, that solves everything. Okay, cool. So, operators. Arithmetic. Plus, minus, multiply, divide. Don't know what that one is. Percent. Don't know what that one is yet. Maybe one of these is divide with remainder, perhaps. I know a lot of times it truncates the remainders. Or, oh, this is probably just a remainder. So this is divide and this is remainder. Just remainder, probably. All right, anyways, comparison. We have equal, not equal, less than equal, greater than equal, less than and greater than. And booleans, not and or. All numbers in the game are floating point numbers, so all other arithmetic operators are floating point operators. Oh, it's just floor after the division. Okay, so this is floor. The double slash there. For assignment operators, you need to unlock the variables unlock. So operators allow you to compare, modify, and combine values. Arithmetic are used to perform common mathematical operations on numbers. What is a double star? Comparisons, yep. Compare values. Results are either true or false. Logic. So plus and minus are used for addition and subtraction. Yeah. Multiply, divide, and floor are used for multiplication and division. Oh, so it does retain the remainder there. Interesting, okay. Floor the same thing, but the result is floored. Oh, okay, so I had these basically backwards when I first looked at them. By the way, 2 is just 2. Modulo is percent. Remainder operator. Oh, that's the remainder. Okay. It's been a while. It's been a while, so that's just the remainder. That's what that is. Okay. So just divides into numbers and returns the remainder. Repeating and subtracting the right number, the left number until the remainder is less than the right number. Power operator. Oh, 2 to the power of 2? Okay. Negative 5 to the power of 3. I see. And comparison, equals and not equals. Yep. Used for all types of values. Okay, so entities bush, not equals false. 3. True. Okay. Less than. Equal, right number. It's true. It's false. Not simply inverse value. Not false equals true. Yeah. Okay. Cool. All right. So now that we have some operators here, till it. Okay. So this is still just a 3. We have carrots first, and then I guess we could just loop the grass. 4 I in, I think it's 1. 2? Is it 2? It's n minus 1, right? So it should be 2. And then we're going to move all of this forward. That should work. All right, let's see what we got. Oh, range 2. Yeah, range. Okay. Let's try this one more time. Excellent. Okay, so instead of range 2, we're going to do get world size since we have operators. And then we're going to minus 2 because we have 2 other crops. That should work just fine. So that will just do 2 rows. Or it'll do, well, we can increment this based on however many entities we have here. In fact, let's do this at the end. And that way everything at the end will be just grassland. So we'll do the fancy stuff, and then we can count how many different crops we're placing for these first 2 rows. And then everything else is just going to be grass. Excellent. Okay, cool. So we can just let that run for a little bit, see what other unlocks we have. Oh, Ah, senses. Drone can see what's under it and where it is. Well, that lets me get rid of some code. I like it. Okay. Drone can see now. Get positions. Okay, start position up to 0. Next position increased by 1. Number items returns how many of an item you have. Get any type and get ground type returns the type of any ground that's under the drone. So do a flip if you're over a bush. Okay, so we wanted to look at get ground type still. None keyword is also unlocked now. None is a value that represents there is no value. For example, a function that has no return statement will actually return none. Get any type returns none if there's no entity under the drone. If you want to find out how many of a particular unlock you have, use the number unlock function. I don't know why we want num unlocked yet. It didn't say get ground type yet. I'm not sure if we have that yet. Let's try it. Let's stop this. If get ground type does not equal soil, we're going to till and then move north. Let's see if that works. Okay. So it's never been defined. You must assign a value to a variable before using it. Let's see if we just type ground soil, perhaps. Is that it? Is it still under unlocks? Automatically unlock things. Oh wow, so you could literally automate, once you get like one of everything, you could automate making it faster and all that? Interesting. Oh, that's actually really cool. Get ground type. There we go. Ah, ground dot. Oh, that's exactly what we want. We literally, this is literally the exact function we wanted. Ugh. All right, we found it. Found it. It's ground dot soil, not parentheses. Okay. I was close. All right, cool. So we can just shove this into the carrot section. And then we don't need to do this entire chunk here. All right. Saves a loop at the beginning. That's nice. We don't have to set up the farm anymore. Cool. All right. So that can just run for a bit. I guess we could use this to alternate. We could simplify the heck out of our code. That would be nice. Okay. Cool. Let's unlock some speed. I guess a bigger farm is better. 3,000 of those. It's nice to see that. I don't think we're breaking anything either. Look at that go. I guess since we have this many, we could do 2 rows of everything. Wouldn't be that big of a change. We're right here to unlock trees, though, so maybe we do some trees. So trees are a better way to get wood than bushes. They get 5 wood each. Like bushes, they can plant grass or soil. Trees like to have some space. And planting them right next to each other will slow down their growth. The growing time is double for each tree that is on tile directly to the northeast, west, or south of it. So you plant trees in every tile, they will take 16 times longer to grow. Okay. So we would want to alternate bushes and trees, perhaps? Or grass and trees? Actually, maybe we could just do it in the grass section. So let's work this out here real quick. Let's get rid of the bush completely, and let's just focus on trees. And then we can alternate tree. We want to alternate carrots and trees and grass. So I guess we can get a lot more carrots as well. Let's try this here real quick. Can I just comment that? No, I cannot do it that way. Okay. There we go. So as long as this is an even number of things right now, this is fine. Just going back and forth. Entities, tree, move north, and then move north. not efficient, but it's probably fine. Let's see what that does. So it should be every other carrot, every other tree, and then carrots again. It's pretty good. Why did it make 2 passes on that? How can I make that 1 pass? I guess we could just save that to I think it's just like that, right? Let's see what happens there. Yeah, that's fine. Okay, cool. Because we were doing 2 planting sections. Okay. Seems good to me. Let's see how we're doing here. So what do we want most right now? We need pumpkins, which are right here. That's 500 wood and 200 carrots. I guess we can figure out watering. How does watering work? So plants grow faster when they're watered. The ground has a water level ranging from 0 to 1. Function get water returns the water level of the ground it's over. Growth speed of plant scales linearly from 1x speed at water level to 5x speed at water level 1. Ground dries over time. It loses 1% of the current water per second, but there's some random variance to this. Maintaining a higher water level will consume much more water than maintaining a low water level. You need water on your plants. One tank of water is automatically out of your inventory every 10 seconds. Upgrading unlocks watering will give you an additional tank of water every 10 seconds. A tank holds 0.25 water. Do I need to water anything right now? Because I think currently we are just growing by the time the drone gets back over. I think this is going to be more important when I get more speed. I want to start breaking this out into functions because this is getting this is getting something else. Okay, well, I saw a lot of pumpkins, so we're going to grab pumpkins. Pumpkins grow like carrots in tilled soil. Planting them costs carrots. Okay. All the pumpkins in a square are fully grown. They will grow together to form a giant pumpkin. Unfortunately, pumpkins have 20% chance of dying once they're fully grown, so you need to replant the dead ones if you want them to merge. When a pumpkin dies, it leaves behind a dead pumpkin that won't drop anything when harvested. Planting a new plant in its place automatically removes the dead pumpkin. There's no need to harvest it. Can harvest always returns false on dead pumpkins. Yield of a giant pumpkin depends on the size of the pumpkin. Oh, wow. It's a good idea to get at least 6x6 size pumpkins to get the full multiplier. Yeah. 1, 3, 4, 5, 6. You plant a pumpkin on every tile and square. One of the pumpkins may die and prevent the mega pumpkin from growing. That is interesting. Okay. So you want to make a little square of the pumpkin. Okay, so that totally throws off my little plan here for just alternating. I was planning on just doing a row of carrots and then a row of pumpkins, a row of carrots, and so on and so forth. I can't do that anymore. Oh, that is wild. I guess the fertilizer would come in useful here because then we can like instantly grow them and then check and then wait until it says it can harvest. Don't harvest it. And then move on. So we need like a new. We need. I need to swap this from I guess pumpkin mode, and then we can just sit on one space. You know, we can sit on one space and make it a pumpkin, and then move on all the way down until we do all the pumpkins. So. Let's see here. Let's see. Fertilizer? Yeah, let's grab it. Okay, some point wait for plants to grow is not efficient. Similar to water, you automatically receive 1 fertilizer every 10 seconds. Plus an extra 1 for each upgrade. Fertilizer can make plants grow instantly. Reduces the main growing time of the plant of the drone by 2 seconds. Side effects. Oh, they're going to be infected? Half of its yield is turned into items of weird substance when harvested. Weird substance can be used in plants, such as the affected algae, the affected status of the plant, and all adjacent plants. So if you call a use item on an infected plant, it will cure it, but if used on a healthy plant, it will infect it. If used on an infected plant that has like neighbors, it will cure the plant and infect the neighbors, vice versa. Oh my god, it's the game of, what was that life or whatever? Oh, there's so much to this game. This is an interesting game. Holy. Because I feel like you had a new window. Where's the new windows then? Plus button. Upper right corner of the screen. Oh. So if we want to do a pumpkin function. So we want... Let's... Okay. We had some... I think we unlocked variables, yes? Not yet. Okay. So variables can be thought as named operators can hold a value. The equals operator is used to declare and store. Okay. The left-hand side of the operator's variable name, you can give it any name you want. The right-hand side is expression, resulting value. We store it in the variable. Okay. Alright. I think I got that. So, we're going to do loop size stored as range get. If you hit backspace one time, you're done. Get world size. There it goes. Times get world size. Okay, so we want to go over every single one of these things, right? Success. And we'll store that as true at the beginning. Okay. And then while we'll set this as finished, actually. We'll set this as false. Okay. And then I think we can do while not false. Oh, actually just while false. Yeah, while false. No, while finished. While not finished. There we go. That's what I wanted to do. Oh, my brain has not done this yet. How do I increment the loop size? I guess it's just plus plus probably. Loop size plus plus. I don't know if that works. Loop current equals 0. We're going to initialize it there. And then we're going to initialize or iterate this one. So we want loop current plus plus. Okay. I don't know. Perhaps. And then if loop current is greater than loop size finished equals true. Okay, so that's how we get out of it. Grab this loop. And for I in range, get world size. We're going to check to see if it can harvest. If it can, we are going to move north. Else. It's not. We're going to till it, and then we're going to plant into these pumpkin. So for it can harvest, we're going to move north, and then we want to iterate the loop current. So loop current equals 0. For I in, I guess we just set this to 6 because we just want to do 6s. Let's do one more here, and then we will tab this forward. I wonder if there's a way for me to reset back to the thing without just typing move east, 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 or whatever. Move to 0 to 0. That's what I would love. I don't know if that's an option. While not finished. How do I let's say it isn't like that. Let's make sure we clear that first. Okay. We can try this. I don't know if it'll work. Okay, so this is not a valid expression. How is that not a valid expression? I'm gonna go read about while loop, I guess. Maybe that's what's... Maybe while finished equals false. Oops. Okay, like that. If can harvest. Okay. Oh, the plus plus maybe. Oh, maybe that it was under. Yeah, so maybe this, it doesn't like this. Loop current equals loop current plus 1. Let's see if we can get move to 0 to 0. I don't know if that's a thing. Oh, what did I... Oh, I must have deleted something here. Oh, just a second. We're not just checking for false harvest. We want to make sure that the pumpkin... and we also need to do just a regular harvest. Right there. We need to check for grass, too. For whatever reason. Else if... Get... Entities grass. May as well pick it up. Harvest. We can check it anyway. We iterate anyway, and then we move north because we want it to be larger than loop size, so that should be just fine. And then finished, we leave the while loop to harvest. Okay, let's see if that works. So trying to use equals on the function get entity type. If get entity, oh, parentheses. There we go. Okay. There we go. Okay, so we're not moving east. So for iron range 6, I think we just do that. All right, let's try that. Very nice. Okay, so this is working. Ooh, it's getting bigger too. Okay, that's strange. Oh. Ah, the move 0, 0 didn't work. Okay. I was hoping that would work. So we got through an entire iteration. You know what? We can, later on down the road, I think we can set these to this down to 6 to make that simpler. I guess we can just put in a command up front. Add command to make farm size 6 by 6. And then we can just get rid of this completely. Alright, we run. Let's see how that's doing. Let's see. Okay, let's run a little output, I guess, to figure out what the heck the loop currents and all that are at. Quick print loop size, make sure that's working. I think it was comma loop size. And then we just need the same thing for right there. See what it's actually doing here, and then I need to open up the output window. So the operator greater than cannot be used in operators 1 and. Okay, let's just play this again. Wish there was a way to clear the output, or have this follow the bottom. Supposed to keep scrolling. Greater than cannot be used on 1 and range. Oh. That's the problem. Range 0. Why do I have the range there? I don't know. I think we can just do that. Yeah, 36. That's what I wanted. Okay, cool. Oh, look at that. It's working. It replaced all the broken ones. Bam! And now it's checking it. And it harvested it. Oh, cool. Look at that go. Oh, that's great, actually. Nice. All right. That's pretty good. I guess we could just loop that if we want to continue. So, while true, and then we just tab this out. Cool. That's pretty rad. And it... Okay. We want this to reset here. This isn't going to change, but the loop current and finish needs to be reset. So there we go. And that should work just fine. Uh-oh. Oh. There we go. There we go. Nice. That's pretty cool. All right, well, we figured that out. I do remember them saying something about if you plant more than one type of crop. Dinosaurs. All right, so we are running out of carrots, so I think we have to run back to the other one. We'll stop this after this harvest is. So I got to get some carrots going because we are spending carrots to do that pumpkin thing. That was fun though. So we have that. I don't know what we're going to use for, but we have it. We should be able to call different functions as well. Like maybe just do a little bit of this and then a little bit of that. I don't see. Was it just under the unlocks? Probably. Lists, functions. Functions. Use the define keyword to define a new function. Define function as this. Use call operator. Scopes to learn about local and global variables and functions. You've seen built-in functions like harvest. You can also define your own functions to allow structuring your code in a modular way. Yes. So get modular. Basically allows you to give a name to a block of code so you can call it from anywhere you want. Function definitions, for example, you could define a function that moves the drone several times. So define move in direction for eye and range, move for... so this is what we want, like I was looking for earlier. It's like to move back to the bottom left or whatever. So definition keyword signals that this is a function definition. Move enter the name of it. Gets bound to and be valid variable name. Use a call function. So the above definition of the following code then moves the drone 10 tiles north and 2 tiles west. When you see that function, you should really think of it as a variable assignment like this. Like with all assignments, you can't use a variable before it was assigned. The statement has to run before any function calls. This code will throw an error. Okay, so return values. So use the return keyword to make a function return a value. So return something, okay. Function defines exclusive or operation that exclusive or returns true if one value is true and the other is false. Tuples allow returning. Oh, we get tuples too. Holy cow. Okay, this is getting deep quick. Alright, we also have default values we use if no arguments are passed. Arguments of the default value cannot be followed by an argument that doesn't have a default value. Advanced function usage. Our value should like any other value. The define statement just acts like an assignment statement. Assign the function to whatever name you give it. Here, f calls the function f, which defines and returns a new function d. The second then executes the return function and performs a flip. These sorts of things. Usually not a good idea because it's hard to say what's going on. Yeah. Functions that take other functions and arguments let you get really creative. Okay. Let's run this one for a little bit. We also have the pumpkin one. How would I confine this? Like if we go bigger than 6x6, if we unlock, say, this one, which is 1K. How can I use those 2 rows at the top and right doing this basically. So I want to have the pumpkin here, and then above that, and to the right of that, I want to do trees and carrots and bushes and all that. And then we'd also want to figure out where we are. Can we... Is that something? Oh, we already have. We have position. So what we can do is at the bottom left, we can have the pumpkin thing running. And then we can iterate it only when it's over that. Okay, this is cool. Okay. We can do that. So we're going to use senses and we're going to set it up so if the position is less than 6 or whatever. So we'll go ahead and expand. And then things are going to get crazy here. So under our main function, we don't need to make the farm size 6 by 6 because we want to use the poly whatever for multiple crops. I would like to call this as a separate modular function. I'm not 100% sure how to do that. I'm just going to maybe move it out of this into the main for right now, and then we can move it back in here once we figure out what we're doing. But what I want to do, we're actually going to just mostly rewrite this. So let me copy this over here. So for I in range, get world size, we're going north basically. We're checking if it can harvest. Right now this is set up for the carrots, right? Let's make the list first actually. How did we do the list? I think we unlocked that, right? Let's try that. Okay. So lists. They are an easy way to store multiple values in a single variable. You can create new lists like this. Lists equals number, boolean, an item. That contains values 2, true, and items. Hey, can also be empty, empty list. You can access an element of list by an index. The index is 0 for the first element, 1 for the second element, 2 for the third, etc. You can iterate over the list using a for loop. So for what we're going to call it in what we already stored, we are going to add, oh, that's how we iterate, I guess. Plus equals? Okay. Sum is now 18. We had this iterate. So the following list method allows you to add and remove elements. List append. Element adds an element to the list. List remove element. So we want to make a list of all of the things that we want to plant, right? We have trees, we have carrots, we have grass, and we have pumpkins, right? So we have... how about we do, instead of loop size, we do pumpkin size? Pumpkin size. And then instead of current, we'll do pumpkin current. Pumpkin finished. Finished. All right. Pumpkin finished false. Pumpkin finished true. Current. Pumpkin size. Current. Good. This and we have this, and we want to combine it. And we do that. Oh man, I'm bouncing all over here. We also want to make a list of all the stuff so we can alternate between grass, trees, and carrots. So crop list equals entities carrot, entities tree, and I guess we want to put nothing, right? So how do we do nothing? I guess false for right now. So it doesn't look like we need to have type list, which is a blessing and a curse, I guess. So we can check to see if it says false first, and then otherwise do whatever these two require, right? For animal range, get world size. We're going to move north, and then we're going to move east. Let's get rid of... Oh, God. Let's see here. How do we do this? Let's make a current crop. Current crop equals 0. Types. Actually, I don't think we need this. We can just hard code the grass. Ish, anyways. So we want crop types. Crop total. Crop total equals we'll just do 2 because we have 2 carrots. We have a carrot and we have a tree right here. We're doing pumpkins separately. Let's get rid of this. In fact, let's code this out a little bit with just some notes here. So if we can harvest, check to see if pumpkin location. If it is, we plant or harvest. If not, we iterate, plant other stuff. So we're gonna place it so 0 in the west and increases the east duration. So we want if it's less than 6, right? Get pause x is less than 6. And I don't know if we can do that. Get pause y is less than 6. Pumpkin location. So we want to do pumpkin stuff, right? Should I put it in here? Entities. Actually, put it at the front, maybe. Yeah, let's put it at the front. Pumpkin. Carrot, tree. We'll still do 2 that we're rotating through, and we will just skip 0, if you will. So we go 1, 2, 1, 2, 1, 2. The 0 is going to be pumpkin. I think that's what... let's see if we can make that work. So we're going to do current crop equals 0. Actually, we can just do this. We'll do that. I don't think we need the crop total either, to be honest. Okay, so because we can probably just call how big this list is. There we go. I think I do want an item in here for... Yeah, you're going back and forth on this. False is grass. How about we just do which plant? Which plant equals this? Crop number equals 0. And we will just do crop number plus equals 1. Current crop equals crop list crop number. Okay, which plant is crop list crop number is greater than or equal to crop list size? Can I do that? Is there a size? Okay, I don't know if we can. Crop list size equals 3. Greater than or equal to 3. So it should go 0, 1, 2, 0, 1, 2. Okay. If it can harvest, which plant is entities pumpkin. Let's set these up at front so we don't have any errors. Pumpkin finished false, pumpkin current 0. Greater than or equal to 36. Harvest. Oh, we gotta check to see if it's harvestable too. If it's pumpkin and if can harvest, true. And if it is 36 blocks or bigger, then we harvest. And so the ground soil tilling needs to happen for carrots and pumpkins, but not for trees or grass, I'm assuming. If which plant is, geez, carrot. Actually, we can harvest immediately. True, harvest, and then ground soil, and then plant entities carrot. Alright, so pumpkin's not done though. We need to make sure it's soil, we till it. So that is harvestable. Then we're still going to say there's no pumpkin there. We're going to harvest that. But no matter what, since this is a pumpkin spot, we are going to till it, if it's not soil, and plant. Then once it's planted, then we're going to move on to the next one, whatever it is. Okay, cool. So it's not loop current that we want. We want to use what? Pumpkin current. And if pump current 0, 0, okay, cool. And now we just need to check to make sure compared against pumpkin size. So I actually don't really need this. We're just gonna use 36 every single time. Else if pumpkin current is greater than or equal to 36. Harvest. That's it. And it should still replant there. Okay, cool. Alright, so if it's a carrot, let's go ahead and set up that. Can harvest true. We're gonna harvest it. Let's till it. Otherwise, plant. Good. And then if which plant is tree, entity is tree. In fact, we can just copy this. We're gonna harvest it, till it, plant it, and then the last one is the grass. None. There's harvest. We don't want to till the tree, but we do want to swap it there. Same thing here. And then we just don't plant anything for grass. All right, that should be it. I think we are good. We don't need any of this anymore. Let's try it out. Let's see if we can get this. Uh-oh, it's already not like the colon. There we go. That looks good. First pass. And run it with a pumpkin. Alright. First error. If get position is less than 6. This need of a... Oh. I think this is it. No, it's not it. We're just making a giant pumpkin farm now. Okay, how do I fix that then? Okay, did I X and Y? It should be doing this stuff off to the left as well. Why is it only doing it on the right? Well, this crop number is working just fine. I am not really sure. I don't know how to do a double check for if. Maybe if I put in parentheses, it might work. Colon is affected here. No. It should only do this pumpkin if both of these fail. It should. Oh, maybe. Did I just miss a colon? Let's try that. No. So X is the west and goes to east. Maybe we go Y first and then X. Maybe that would. I don't know if that will help or not, but let's see what happens here. Oh, that does work. I wonder why that does work. Is it going to go all the way over here though? No, sure. I'm not sure. We'll find out in a second. Oh, no, it's just still on carrots for some reason. Oh, because the else is there. It's interesting that it doesn't cycle that. I guess we'll figure that out next time. Cool. We got some semblance of work, but we got a little bit of bug to work out. Maybe you guys can help me out in the comments. But I will be returning to this very soon. I want to get out probably another one here the next couple days until we figure out where to stop with this. This is a great game though. Thanks so much for watching, and I will see you next time.